When I was young, obviously, initially, because I was a girl, my parents wanted me to become a medic. But I was really into engineering, and so I didn't want to do that.
What brought me into a subject is the passion for science, I guess. I love that scientific, inquisitory kind of thinking.
I had a really big interest in arts and games. I was only I went to university to do something along the games route that has actually brought me onto kind of simulations and other stuff that you can do with computer animation and visualization.
It was the communications particularly. I was so fascinated with the amount of things that you can do with the different hardware that are connected to each other.
I really like the scientific methodology. I like being able to do experiments and see results, and I like the variety that all this brings.
So my area of research is plastic electronics or organic electronics.
Nano devices, currently for energy harvesting.
Task allocations and resource scheduling techniques.
I work on a subtopic of artificial intelligence called computational argumentation.
I'm a CAD modeler who designs realistic simulations.
It's exciting because there are endless possibilities for what we can do with computers. We've made a lot of progress over the last few decades, but there are loads of open research problems.
Recently we started to watch all driverless cars or smart cities that controls the environmental behaviors. Or we're seeing Amazon, how they're preparing orders. So these are all part of autonomous systems, and they're going to be part of our daily lives.
So what we do in organic electronics, we try and replace conventional materials such as silicon, which tends to be rigid, with conducting plastics. It provides new application in terms of flexibility. So for instance, you could have smartware, flexible displays, so bendable displays which are quite thin. You could even have electronic wallpaper, because the electronics is so cheap to produce. The opportunities for applications are vast.
Nano stands for 10 to the minus 9 meter, so you need to have 9 zeros and then you have a number. So it's a very tiny little layer. The prediction is that all these developments in electronics in this area will help to creating devices that will help monitoring our health, with environmental issues, with creating new sustainable sources for clean green energy, because we are scaling so much. There are so many transistors, billions of transistors in such a small area. It's probably the most sophisticated technology that we as humanity made.
I think being in engineering in general provides a vast opportunity career-wise. It doesn't have to be just in technical side. And this is where the engineering field is going, particularly electrical. It's becoming more and more interdisciplinary, multidisciplinary.
So there are all sorts of subjects that are of relevance. We look to psychologists for theories about how humans think and how humans behave. We look to philosophy for ethical issues associated with the development of artificial intelligence. We look to linguistics in other areas of AI when we're trying to do natural language processing applications, and that's what makes it exciting to me.
I would imagine the right person in the field would be somebody who doesn't necessarily need to know a lot about the background knowledge of the subject, but I think it's the need to learn more and the need to look at new areas of application.
I think it's pure passion. Obviously you need to like what you do, or even love what you do, and that will give you a very good start in the industry anyway.
I think we as the humanity needs the brightest people around the globe choosing engineering as career, because all these issues that I have mentioned, environmental, energy, sustainability, healthcare, is the engineers will be driving forward. So just go for it.